Download this code from codegive.com, link in the description below. Video 16 OData Service Batch Process Get Part 1, a deep dive with code examples. This tutorial will provide a comprehensive breakdown of Video 16 in a, presumably SAP, OData Service development context, focusing on the get part of batch processing. We'll cover the concepts, motivations, implementation steps, potential pitfalls, and best practices, supplemented with code examples in ABAP, the language commonly used for SAP OData services. Disclaimer *: This tutorial is based on the assumption that Video 16 refers to a tutorial within an SAP-centric OData service development course. If the actual content deviates significantly, some sections might need adjustments. However, the core principles of OData batch processing and GET operations will remain relevant. 1. Understanding batch processing and its relevance. Problem Sending numerous individual requests to an OData service can be inefficient. Each request incurs overhead in terms of network latency, server-side processing, and potential authentication. Imagine retrieving data for 100 customers, 100 separate requests. Solution: Batch processing. OData batch processing allows you to bundle multiple operations, create, read, update, delete, crud, into a single HTTP request. The server then processes these operations in sequence and returns a single response, drastically reducing overhead. Benefits: improved performance, reduced network latency and server load. Increased efficiency, simplifies client-side coding and resource management. Enhanced user experience, faster response times, leading to a more responsive application. Transactionality, limited. While not a full-fledged ACID transaction, batch processing provides a degree of atomicity. If one operation within a batch fails, the entire batch might be rolled back, depending on the implementation. OData Batch Standard. The OData specification defines the standard for structuring batch requests and responses using the multipart/mixed content type. 2. Focus on GET operations within a batch. This tutorial primarily deals with GET operations within a batch request. This means you're combining multiple read requests, queries, into a single request. Use cases for batch GET operations. Retrieving related entities. Fetch customer details and their associated orders in one go. Performing multiple queries. Get all products in categories A and B with a single request. Populating a user interface. Load various data points required to render a screen with a single batch. 3. The structure of an OData batch request. Focus on GET. An OData batch request uses the multipart/mixed content type. It consists of a preamble, a set of change sets, for write operations, and / or retrieve operations, for get requests, and a final epilogue. Since we're focusing on get, we'll primarily discuss retrieve operations. Here's a simplified breakdown of a batch request containing 2 get operations. Explanation **** post /sap /opus /odata /sap /your _service $batch, this is the endpoint for batch processing. Replace your _service with the actual name of your OData service. Content type, multipart/mixed, boundary equals batch _0001, specifies the content type and the boundary string used to separate the individual operations within the batch. *batch _0001, the boundary string. Each operation within the batch is delimited by this string. Content type, application/HTTP, indicates that the body of this part is an HTTP request. Asterisk content transfer encoding, binary, specifies the encoding of the HTTP request. Asterisk get customers, $filter equals city EQ New York HTTP/1.1, this is a standard OData GET request. It fetches customers where the city is New York. Asterisk accept, application/JSON, odata.metadata equals minimal, specifies that the client prefers the response in JSON format with minimal metadata. Asterisk batch _0001 the closing boundary string, indicating the end of the batch request. Key points asterisk boundary the boundary string must be unique and used consistently throughout the request. Choose a string that's unlikely to appear in your data. HTTP method use get for retrieval operations. OData query options you can use standard OData query options like $filter, $select, $expand, $order by, $top, $skip within the GET requests in the batch. Accept header crucial for specifying the desired response format, JSON, XML, etc. No body for GET GET requests should not have a body. All parameters are passed through the URL. 4. Implementing batch processing on the server side, ABAP example. Let's look at how to handle batch requests containing GET operations in ABAP, the language typically used for SAP OData service implementations. We'll assume you're using the SAP Gateway Service Builder, transaction SEGW. Assumptions you have an existing OData service. You want to support batch processing for GET requests on a specific entity set, example customers, products. Steps 1. Redefine the execute_batch method in your data provider class, DPC_EXT class. This is the central method for handling batch requests. You need to redefine it in your DPC_EXT, data provider class extension, class. Explanation mo_context-get_batch_handler, retrieves the batch handler object. LR_batch_handler-get_request_boundary, gets the boundary string from the request header. LR_batch_handler-parse_request, parses the incoming batch request into individual parts, storing the results in LT_batch_parts. Looping and processing the code iterates through each part of the batch. The case statement distinguishes between different HTTP methods, get, post, put, delete. Process_get_request, defined below, this method handles the actual processing of the GET requests. LR_batch_handler-add_response, adds the response from each operation to the batch handler. LR_batch_handler-set_response, sets the overall batch response. Exception handling crucial for handling errors during parsing or processing. To implement the process_get_request method This method is responsible for executing the individual GET requests within the batch. Explanation is _batch_part URI, contains the URI of the GET request, example customers, $filter equals city EQ New York. mo_context-create_request_context_from_URI, parses the URI and creates a request context object. This object holds information about the entity set, key predicates, if it's a get_entity request, and query options. *LR underscore request underscore context dash get underscore entity underscore set underscore name, retrieves the name of the entity set from the request context, example customers. *MO underscore model dash get underscore entity underscore set, gets the entity set object from the odata model based on the name. *LR underscore entity underscore set dash get underscore data, this is the core of the get operation. It calls the appropriate underscore get underscore entity set or underscore get underscore entity method that you implemented in your DPC underscore ext class to retrieve the data. *IO underscore data underscore provider dash create underscore media underscore resource underscore from underscore data, converts the retrieved data, LR underscore data, into the desired response format, JSON or XML. The IO underscore data underscore provider is typically me-abap/if underscore mgw underscore odata underscore cm underscore srv equals get underscore data underscore provider. Setting response status the code sets the HTTP status code, 200 for success, and content type in the ER underscore response object. Error handling handles exceptions and sets appropriate error codes and messages in the ER underscore response. 5. Considerations for $expand in batch GET requests. If you're using the $expand query option within your batch GET requests to retrieve related entities, you need to ensure that your _get entity set and _get entity methods correctly handle the expansion logic. This often involves fetching the related entities and populating the navigation properties in your data model. Example *. Let's say you have an entity set customers with a navigation property orders to the orders entity set. Your batch request might contain. In your customers _get entity method, you would need to 1. Retrieve the customer data based on customer ID equals 123. 2. Check if $expand equals orders is present in the request context. 3. If so, fetch the orders associated with that customer. 4. Populate the orders navigation property in the customer entity with the retrieved order data. 6. Testing your batch implementation. *SAP Gateway Client, transaction/if/gw_client. The SAP Gateway Client is a useful tool for testing your OData services. You can construct the batch request manually and send it to your service. Remember to set the correct content type and boundary. *REST clients, Postman, Insomnia REST clients like Postman and Insomnia are also excellent for testing OData services. They offer features for easily creating and sending HTTP requests, including batch requests. *unit tests writing unit tests to verify the behavior of your execute_batch, process_get_request, and _get entity set /get entity methods is crucial for ensuring the correctness and stability of your implementation. 7. Best practices. Keep batch operations focused. Design your batch requests to perform logically related operations. Avoid mixing unrelated operations in a single batch. Limit batch size. Large batch requests can consume significant server resources. Set a reasonable limit on the number of operations allowed in a single batch. Consider using paging to retrieve large datasets in multiple batches. Error handling. Implement robust error handling to gracefully handle failures during batch processing. Provide informative error messages to the client. Security. Ensure that proper authorization checks are performed for each operation within the batch. Don't assume that because the initial batch request is authenticated, all operations within it are automatically authorized. Performance tuning. Monitor the performance of your batch processing implementation and identify any bottlenecks. Consider using caching or other optimization techniques to improve performance. Logging and auditing. Log relevant information about batch requests, such as the number of operations, processing time, and any errors encountered. This is essential for debugging and auditing purposes. Use standard OData libraries. Leverage the standard OData libraries provided by SAP to simplify development and ensure compliance with the OData specification. Avoid reinventing the wheel. Properly encode URIs. Be sure to properly URL encode any special characters within the URIs contained in your batch requests. This will prevent parsing errors on the server side. 8. Potential pitfalls. Incorrect boundary string. Using an incorrect or inconsistent boundary string will cause the batch request to fail. Malformed URIs. Invalid or malformed URIs within the batch request will result in errors. Missing content type header. Forgetting to set the content type header or setting it incorrectly, example application/JSON instead of multipart/mixed, will cause the request to be rejected. Authorization issues. Failing to perform proper authorization checks for each operation within the batch can lead to security vulnerabilities. Resource limits. Exceeding resource limits, example memory, CPU time, can cause batch processing to fail. Encoding problems. Incorrect character encoding can lead to parsing errors, especially when dealing with non-ASCII characters. Ensure that you're using a consistent encoding, example UTF-8. 9. Advanced topics, beyond the scope of this basic tutorial, but important to be aware of. Change sets. Change sets are used for grouping write operations, post, put, delete, into atomic units. If one operation within a change EZ fails, the entire change EZ can be rolled back. Cross-referencing within a batch. You can use content IDs, example $1, to refer to the results of previous operations within the batch. This is useful for creating relationships between entities. Asynchronous batch processing. For long-running batch operations, you can consider using asynchronous processing, where the server processes the batch in the background and notifies the client when it's complete. Conclusion. This tutorial has provided a detailed overview of OData batch processing, focusing on get operations. By understanding the concepts, structure, and implementation steps outlined above, you can effectively leverage batch processing to improve the performance and efficiency of your SAP OData services. Remember to test your implementation thoroughly and follow best practices to ensure a robust and secure solution. This is just part 1, which covers the foundational elements. Part 2 would likely cover more complex scenarios such as error handling, $expand, and deeper dives into the ABAP implementation. Good luck.